Hello fellow programmers and welcome to a new video on the Future Programmer YouTube channel about boundaries with regular expressions in Python. So without further ado, let's go ahead and get started looking at this topic. With regular expressions, we can use boundaries to define where exactly in a text a match needs to occur. For example, using boundary specifications, we can match a pattern only if it occurs as one singular word. So let's import the RE module and begin talking about this. The first thing we're going to talk about is word boundary. This is the first type of boundaries, and it is indicated using the character \b. This character is known as a word boundary. In other words, we can use this character to ensure that a match against a pattern could only be made if the matched text is a word. And what that means could be more clearly seen if we take a look at an example. Here we have the word apple. This is the pattern, and we have a bunch of texts that we're matching this pattern against. I have an apple, I have a pineapple, and I have some apples. Notice that apple matches obviously apple, but also apple also matches apple here, even though it is part of the word pineapple. And apple also matches the word apples, even though there's an S after the word apple. So how could we ensure if in a scenario we want to only match the word apple and not if there is some prefix or suffix added to the word apple? Well, we could use \b. Notice how all of these patterns are raw strings or R strings because we want the backslash characters to be treated as such, as literal backslash characters. So here we're matching the same text against a different pattern. And the only modification to this pattern is the addition of a \b character to the start and end of the word apple. The difference it's going to make is that this pattern, this new pattern here, is going to match I have an apple, but it is not going to match I have a pineapple or apples. Now we can take a look at this. We see there's a match object with apple, but not with pineapple or apples. To be a little bit more precise, \b defines a boundary between a word character and a non-word character. If at the location of the \b character there is such a boundary, so on one side there is a word character and on the other side there is a non-word character, then a match could be made, if obviously the pattern actually matches. Otherwise, a match will not be made. So let's take a look at this example one more time. We have apple, the word apple. Before the word apple, we have specified a word boundary, and after that, we've also specified a word boundary. So let's take a look at apple. Before the word apple, we have a space. This is a non-word character, and A is a word character. That means where my cursor is right now, there is a word boundary. And obviously, since this is at the end of the string, E is a word character, and since there's nothing afterward, this also counts as a word boundary. On the other hand, we have pineapple. Pineapple at the end, obviously there is also a word boundary as specified here, so that works. However, before the word apple, this word boundary does not match because where my cursor is right now, there isn't a word boundary since before the boundary, there should be a non-word character, but right now there is E, which is very much a word character since it's a letter. And after that we have A. So this does not satisfy the condition that we've set for a word boundary. Therefore, even though apple here does match this part, because of the lack of a word boundary here, it does not match the \b here, so we don't have a match. And same deal here. So we have apple, even though before the A, we have a word boundary. This is a word boundary. Between the E and the S, there isn't a word boundary, even though we want one, so there's also not going to be a match here. And these examples will show you what are and what are not considered word characters. As you'll see, characters in the class \w, so the numbers, the letters, etc., are considered word characters, whereas those in backslash uppercase W are not considered word characters. They're considered non-word characters. So we have the same pattern 5 times, backslash b Python. So notice how even though up here we have backslash b before and after a word, we don't have to do that. We can have it just before or just after, or we can have both, obviously. So we have backslash b and then the word Python. I dash love dash Python. This is going to match because dash is a non-word character, whereas p is a word character. So there is a word boundary, and that satisfies the condition. Same deal here. We have a space and a word character, so that will also match. We have a dot, which is a non-word character, and a p, which is a word character. So we can see all of these matches will be made, and we have Python, Python, and Python. On the other hand, here we have the same pattern, however the texts are different, and we can see p, of course, is a word character. However, 1 is also a word character because it falls under the class backslash lowercase w, and underscore is also considered a word character, so there is not a word boundary in either of those places. Therefore, we don't get any matches in this case. And we also have the backslash uppercase b, which has the opposite behavior of backslash lowercase b. It matches a position that is not considered a word boundary. So here we want to match, essentially what this pattern is specifying is we want to match a word that ends with the suffix, I suppose, city. However, it does not match the actual word city. It has to have something before that, and it has to be a word. So basically, backslash lowercase b wants on one side a word character and on the other side a non-word character, whereas backslash b wants the same thing on both sides. So in this case, we want c, a word character on one side, and on the other side, some other word character. So therefore, I is a word character. So there is this satisfies the backslash uppercase b. This also satisfies the backslash uppercase b. This does not because we don't have anything before that. So we will get 2 matches and a none. Now let's talk about line boundaries, which are specified using the characters, the caret, and the $sign. These characters indicate the start and end of a line or string in regex respectively. So the caret indicates the start of a string, whereas the $sign indicates the end of a string. So for example, caret ABC would only match ABC if A is the first character of the string. So ABC is literally the first 3 characters of the string because this indicates the start of the string. On the other hand, ABC $sign would only be matched if ABC are the last 3 characters of the string. And of course, these 2 can be used in combination as well. So we have here a pattern. We have caret and then hello world. And because H here is not at the very start of our text, we have a space here. Therefore, we won't get a match. We'll see none. And here we have hello world, and we have a $sign at the end, indicating we want D to be at the very end of our string. And because we have a space here, D is not at the very end of the string, therefore we get none. And here we have the combination of the 2 things. We have a caret at the start and a $sign at the end, indicating, well, this is literally going to be the entire string. It will start with the letter H and it will end with the letter D, with these letters in between. So we have hello world with a space in front of the H and a space after the letter D. Therefore, there is not going to be a match because we have stuff before and after this string. Now, if we remove these spaces before and after the hello world text, then we'll see a match object generated with the text hello world. Another example would be if we want to check if an entire text are all numbers. So for example, here we have a string that are not all numbers. A little bit tricky here, but we can see there is actually a letter O, an uppercase letter O here, whereas this is all numbers. So what this pattern here is doing is we have, of course, a raw string. It starts with a caret, so that means it starts with a caret and ends with a $sign, which means whatever is in between is going to be the entire string. and this entire string are all going to be within the class \d, so numbers, and plus means there's at least one occurrence. So that means we want this entire string to be all numbers. And this is not the case, but this is going to be the case. So this will be none and this will be a match. And you'll see that confirmed. If we get rid of this, of course, we'll get two matches. But since this is a letter, which does not fall under the category of \d, we'll get none. To summarize the lesson, you learned today how to use \b, \b, the caret and dollar characters to indicate the positional requirements for regex matches in terms of boundaries of words and strings.